In our previous lesson, we learned about the laws of exponents, which helped us to understand exponents that had positive or negative numbers, even exponent expressions that had zero as an exponent. In this lesson, we're going to learn how to multiply exponent expressions together. And for that, we'll learn how to use the product property. First, let's take a look at this example, and it's going to help us to understand how the product property works. We can see here that we have two exponent expressions being multiplied together. We have x squared times x to the fourth power. If we expand these exponents out, we can see that x squared is x times x, and x to the fourth is x times x times x times x. And all of these values of x are being multiplied together here. Well, notice that it really comes down to us just having 6 x's being multiplied together. And since exponents represent the same value being multiplied together over and over again, we could represent this as x raised to the 6th power. Now, if we take a closer look at our original exponents that we started with, we had x raised to the power of 2 times x raised to the power of 4. And when we multiplied them together, the result was x to the power of 6. So what we really just did was add the exponents together. 2 plus 4 gives us 6. And that's really how the product property works. As long as the exponents have the same base and we're multiplying them together, all we have to do is add the exponents. So to put that together, here's the product property of exponents. It's used to multiply exponent expressions that have the same base, and that's very important. In our previous example, we could multiply them together because both expressions had x as their base. Now, if we write this as a general rule without using specific numbers, we can set it up like this. X raised to the power of a times x raised to the power of b combines to give us x raised to the power of a plus b. So whatever numbers we have in the exponents where we see a and b, we would just add those numbers together to see what the final expression simplifies to. Let's take a look at some more examples. Here we have m times m raised to the 9th power. And our instructions are just to simplify this. And since we have multiplication going on, we would multiply these values together in order to simplify them. Now notice the first m does not have an exponent there. But if it's just one m, then we're really saying that the exponent could be 1. So whenever there's no exponent written there, we can write a 1 as the exponent. And now we see that we have two expressions being multiplied together. They have the same base of m. So now we just need to add the exponents together. So we keep the base, we have our m there, and add the exponents of 1 plus 9, and that will simplify to m raised to the power of 10. In this example, we have y squared times y raised to the negative 5th power. Even though we have a negative exponent there, the process is still the same. The exponents have the same base of y, so that allows us to be able to multiply these expressions together. So we keep our base the same as y, and we add the exponents together. 2 plus negative 5. And when we add those exponents, we get y raised to -3. And we could stop here. Our expression is simplified. However, we normally don't want to see negative exponents in our final answer. So we can apply the law that we learned in our previous lesson about how to change negative exponents into positive ones. And to do that, we take the reciprocal and remove the negative sign from the exponent. So then it becomes 1 over y raised to the power of 3. Now for this example, we're going to see that our variables have coefficients with them. So notice we have 3 times p squared being multiplied by 5 times p to the 7th power. So those numbers that we see to the left of our variable p, we call those coefficients. And it just means that those numbers are being multiplied by that variable. So the 3 and the 5 are coefficients. But since we're just multiplying these expressions together, in order for us to simplify this, we're going to multiply those coefficients together. So we're going to simplify this in 2 steps. First, we'll multiply those coefficients, and then we'll go on to multiplying the parts that have the variable with the exponent. So we have 3 times 5. That will give us 15. And now we can move on to the p squared times p to the 7th power. And when we multiply exponent expressions that have the same base, we just add the exponents together. So that part will become p raised to 2 plus 7. And then from here, we can just add those exponents together. The 2 plus 7 will become 9. And now we have 15 times p raised to the 9th power. We could leave it like this. However, since the 15 is being multiplied by p to the 9th, we don't have to have a multiplication symbol in between them. We can just write them right next to each other, and that's enough for us to know that we have the 15 being multiplied by p raised to the 9th power. And it would look like this: 15 times p raised to the 9th power without the multiplication symbol in between. And that's our final answer there. Let's look at another example that has coefficients next to the variable. So we have -6 times k to the 3rd power being multiplied by 2 times k to the -8th power. First, let's focus on our coefficients, -6 and 2. We'll multiply those together and get -12. Now we can focus on our variable k that has exponents, and we're going to multiply k to the 3rd times k to the -8th. And remember, when we're multiplying exponents that have the same base, in this case they both have a base of k, we just add the exponents together. So that part becomes k raised to 3 plus -8. And now we just need to simplify the exponent part by adding 3 plus -8. So everything becomes -12 times k to the -5th power. And notice, since we have a negative exponent, we'll normally want to rewrite that part so that we have a positive exponent. And our trick for doing that is to take the reciprocal and remove the negative sign. So that part is going to become a fraction with k to the 5th at the bottom as the denominator and 1 at the top as the numerator. So we'll have the -12 times 1 over k to the 5th power. And now we can clean this up a little bit more to put this all together, and we can even represent it as one fraction. So if we multiply that -12 times the 1 that's at the top as the numerator of our fraction, we can make the numerator negative 12 and then keep k to the 5th as the denominator. So we can write it like this: negative 12 over k to the 5th power. And you could keep the negative sign with the 12 as the part of the numerator. That will be fine. Or you could just put the negative sign in front of the whole fraction like you see here. Either way, it still represents the same value. It still shows that we have a negative fraction. So there's our final answer: negative 12 over k to the 5th power. Now we have a cubed times b to the 4th being multiplied by a to the 9th times b to the 10th. We have a little more going on in this one, don't we? We still have two exponent expressions being multiplied together, but each of those expressions has two variables. Each one has a and b. And we can see that a cubed and b to the 4th are being multiplied together because those variables are right next to each other with no symbol in between. So whenever you see that in algebra, that means that they're being multiplied together. So we really just have a whole bunch of exponent expressions being multiplied together here. But the process is going to be the same. Since we do have more than one variable though, we're going to focus on just one variable at a time. So first let's focus on our expressions that have a as the base. We can combine these two parts because they do have the same base of a. So we're going to keep the base the same and add the exponents. So that part becomes a raised to 3 plus 9. And then we move over to our exponents that have b as their base. And we can combine those together because they have the same base. So we have the base of b raised to 4 plus 10. And now we just need to simplify those exponents. That will become a raised to the 12th times b raised to the 14th. And typically, since we want to simplify this expression, we won't leave the multiplication sign in between. We can just write these variables right next to each other to indicate multiplication. So to put it in its final format, we would just write it like this: a to the 12th times b to the 14th. Let's look at one more example. Here we have x raised to the negative 5th power times y to the 8th being multiplied by x to the negative 2nd power times y. We have a lot going on here, don't we? So let's take a close look and come up with a game plan before we start to simplify this. We have more than one variable again. We have x and y. So we know that we'll need to focus on one variable at a time. We also have some negative exponents. So that means at some point we may need to apply the law of negative exponents. And we also have y at the end there that doesn't have an exponent at all. But we do know that when there's no exponent, that means we have just one of the y variable. So we could write a 1 there as an exponent. Now we're ready to go ahead and apply the product property. So let's first focus on x. Here we have x to the negative 5th times x to the negative 2nd. We're going to keep the base the same and add the exponents. So we get x raised to negative 5 plus negative 2. Now we'll move on to y. Keep the base the same and add the exponents. So it'll become y raised to 8 plus 1. Now let's simplify those exponents. We'll get x raised to negative 7. Be careful when you're adding those negative numbers. And then y raised to the 9th power. We do have a -7 there as that exponent. So let's go ahead and apply the law of negative exponent so that we can change this into a positive exponent. So we'll take the reciprocal and remove the negative sign. And we can just bring down y to the 9th. We didn't need to change that part. Now we can multiply these together so that we can see them all as one expression. Okay? So when we're multiplying a fraction times an expression that's not a fraction, we multiply the numerator times that other part. So we're going to have 1 times y to the 9th power is our numerator over x raised to 7. So our final answer would simplify to just y to the 9th power over x to the 7th. And there we go. Everything is simplified. We have just one exponent part that has x and one part that has y. We combined our x's together, combined our y's together, and we have no negative exponents. So now we know that our expression is fully simplified. So just remember, when you're tackling these problems, just focus on one variable at a time. Here we had just the two variables, x and y. But sometimes you may see some problems that have even more variables. As long as you focus on one variable at a time though, you can keep track of your steps and make sure that your final answer is correct.